Okay, May-June 2018, Paper 2, Variant 1. Question 1. A length of cotton is measured between 2 points on a ruler. When the length of cotton is wound closely around the pen, it goes around 6 times. What is the distance once around the pen? So the distance of the whole length of cotton is what? It started at 2.4 centimeters, and it ended at 15.6 centimeters. 15.6 centimeters. So the distance is actually 15.6 minus 2.4, which is 13.2. This is the whole length of the of this piece of cotton. Okay, this is not once around the pen. How many times what did it wound around the pen? It wound around the pen 6 times. So 6 times. So you need to divide this number by 6, which would end up being 2.2 centimeters. When does an object fall vertically through air reach terminal velocity? Terminal velocity means that it reached a constant speed. When the acceleration of the object becomes negative. لا. When the acceleration is equal to g. No. When the air resistance equals the weight of the object. Yes. When the air resistance becomes equal to the weight of the object, the resultant force on the object is 0. Therefore, it's moving at a constant speed. Okay. A car is moving along a straight horizontal road with constant acceleration. With constant acceleration, meaning that the speed is increasing constantly at a constant rate. Which graph shows the motion of the car? A, it's at rest. B, distance time graph, meaning that it's moving at a constant speed, not constant acceleration. B and C are the same graphs. This is a constant speed and this is a constant speed. D is a constant acceleration. Okay, question 4. Diagram 1 shows a beam balance a beaker with a wire loop balances the stranded masses. Okay, so you have a spring and you have a beam balance. The experiment is repeated with the same apparatus on the moon where the acceleration of free fall is less than on Earth. We took this same experiment and we repeated it on the moon. Which statement describes what happens on the moon? The only difference is that on the moon, we have a gravitational acceleration less than on Earth. So, on Earth, the spring extends by 5 centimeters. And we know that in Hooke's law, the force and extension are directly proportional. The force, which is the weight, the force is the weight on Earth, weight equals mg. G, gravitational acceleration on Earth, is 9.8 meters per second squared. On the moon, it's much less. Okay, so on the moon, the force or the weight would be much less, and therefore the extension on the moon would be less. But the beam wouldn't be affected. The weight would be less, yes, but the weight on both sides would be less. So the weight on both sides would be less, meaning that it would still balance on the moon. The beam balance is balanced, and the spring extends by 5 centimeters. No, by less than 5 centimeters. Okay, by less than 5 centimeters. Why? Because the weight on the moon is less. Okay, question 5. An object always has mass but doesn't always have weight. What must be present and acting on the mass to have weight? A gravitational field, a set of scales, displaced water, friction due to air resistance. Definitely, it needs a gravitational field. A force acting on a moving ball causes its motion to change. This force stays constant. What makes the force produce a greater change in the motion of the ball? You have force and you have a mass on the ball. We need to produce a greater change on the motion of the ball. How can I produce a greater change on the motion of the ball? Decreasing the total mass of the ball. Definitely. F equals ma. If it's the same force and you need to increase the acceleration, so you might need to actually decrease the mass in order for the acceleration to increase. Okay. Yeah, a balloon and the mass are attached to a rod that is pivoted at P. The balloon is filled with helium. The rod is horizontal and stationary. Which action causes the rod to rotate clockwise? We now need the rod to rotate clockwise. What is clockwise rotation? If you look at the clock, it rotates this way. So basically, you need the rod to rotate upwards in this way. So the balloon and the mass, okay, are now balanced. They are now balanced. We can solve this question numerically. What do I mean by numerically? The distance of the balloon is 30 centimeters and the distance of the mass is 20 centimeters. We can give them, okay, we can give each of them a force, a weight, okay, a force for the balloon, upward force, an upward force and a downward force of the mass, which would be the weight. We can give just any two numbers. For example, the balloon has an upward force, let's say, of 2 newtons. 2 newtons, and the mass has a downward force of 3 newtons. Why? Because 2 times 30 would be equal to 3 times 20, 60 newton dot centimeter and 60 newtons dot centimeter. Now, you actually need the clockwise moment to be greater than the anti-clockwise moment. You need 2 newtons times some sort of distance to be greater than 3 newtons times another distance. Let's check out the answers. Move both the balloon and the mass 10 centimeters to the left. If we move them both 10 centimeters to the left, meaning that the balloon would be at a distance of 40 and the mass would be at a distance of 30. So let's try it out. 40 times 2, 40 times 2, which is 80. And then the other one would be 30 times 3, which is 90. This means that the anti-clockwise moment is greater than the clockwise moment. This means that the anti-clockwise moment is greater than the clockwise moment. So this is wrong. لا. So answer A would be wrong. Let's try out the other one. Move both the balloon and the mass 10 centimeters to the right, meaning that the balloon would be at 20 centimeters and the mass would be at 10 centimeters. 20 times 20 times 2 is 40. What about 10 times 3? Oh, this is 30. This means that the clockwise moment is greater than the anti-clockwise moment, and therefore it would rotate in a clockwise manner. Yeah. Question 8. A car is moving in a straight line on a level road. Its engine provides a forward force on the car. A second force is equal size acts on the car due to resistive forces. Which statement describes what happens if you have a forward force and a backward force, a driving force and a resisting force, and they're both equal, of equal size? This means that the resultant force is 0, and therefore the car is moving at a constant speed. Driving force and the resisting force, they're both equal, meaning that the car is moving at a constant speed. Which expression gives the momentum of an object? Momentum is mass times velocity, mv, mass times velocity. As energy is transferred into different forms, it eventually becomes dissipated. What does this mean? What does this mean? Dissipated means that it gets lost. Okay, it gets lost to the environment. All of the energy disappears. It doesn't disappear. It changes into another form. The energy finally changes into every possible form of energy. Definitely not every possible form of energy, into 1 or 2 or 3 other types of energies, but not every possible form of energy. The energy spreads out among the objects and their surroundings. Yes, it's lost to the objects and the surroundings around it. The total amount of energy becomes this. No, it's the same. It is the same amount of energy. A ball of mass 1.2 kilograms is dropped from a height of 30 meters. As it falls, 25% of its initial gravitational potential energy is transferred to thermal energy. What is the kinetic energy of the ball just before it hits the ground? This is easy. Initial gravitational potential energy would be GPH is equal to mgh. Gravitational potential energy, GPE, not GPH. Gravitational potential energy equals mgh, which is 1.2 times. Mister, this was an old exam. Okay, you can use 10. But for the sake of memorizing the number, it should be 9.8. 1.2 times 9.8 times the distance, which is 30. Yeah, can we calculate this? Yes, 1.2 times 9.8 times 30 is around 352.8. Okay, 352.8, which is 353 joules. 353 joules. So the total energy was around 360 joules. Total initial energy was around 360 joules. As it falls down, it loses 25% of its initial gravitational potential energy. So you have 75% remaining. 75% of the initial gravitational potential energy is remaining, which has transferred into kinetic energy. Basically, 353 times 75%, which is 0.75. Okay, 353 times, okay, 0.75 is around 265 joules, 270 joules. That's it. Okay, you lost 25%, you have 75% remaining. Yeah. uh a girl hangs by her hands from a bar in the gymnasium. She pulls herself up until her chin level is level with the bar. The mass of the girl is 48 kilograms, a distance of 0.25 meters. She does this in 2 seconds. What is the useful power? Power. Yeah, what is power? Power equals energy over time. Power equals energy over time. Energy in this case would be the work done. Work done over time. So what is work done, mister? It's force times distance over time. What is the force? It's the weight. Can I find the weight? Yes, you can find the weight. You can find the weight. Weight equals mg. So 48 times 9.8, which is around 480 or less, times 9.8 is 470. So 470 times a distance of 0.25 meters over the time, which is 2 seconds, times 0.25 divided by 2, 58.8, which is almost equal to 60 watts. Yeah. Energy over time. Hello. 4 identical beakers are filled with equal volumes of liquids P or Q. At which point is the pressure the least? Least pressure. Least pressure. So we need the least depth. Least depth, which would be B or D. Okay, and the least density. The least density. Liquid P is more dense than Q. Liquid P is more dense than Q. So you need to choose liquid Q, and the answer would be D. The greatest pressure in this question would be A. The greatest pressure, but the least pressure would be D. An oil tank has a base area of 2.5 meters and is filled with oil to a depth of 1.2 meters. The density is 800. What is the force exerted on the base of the tank due to the oil? Pressure. We can solve this question using pressure. Pressure equals force over area, or you could say that the pressure equals rho gh. Pressure equals force over area, which is also equal to rho gh. You need the force. So we can say that the force is equal to rho gh times the area. صح. Density 800 times 9.8 times the height or the depth 1.2 times the area, which is 2.5. Yeah, you can calculate this. 800 times 9.8 times 1.2 times 2.5 is 23,520. 23,520, which is very close to 24,000. Okay, yeah. When molecules of a gas rebound from a wall of container, they experience a pressure. Or the wall experiences a pressure. What causes this pressure? What causes this pressure? The change in momentum. The change in momentum. Why? Because as it hits the wall, the direction changes, um, even if the magnitude of the velocity doesn't change, the direction of the velocity changes. When the direction of the velocity changes, this means that it is exerting a force on the wall, which is momentum, or actually impulse. When you change the momentum, you are exerting an impulse. A student wishes to calibrate mercury. This question has been removed. Okay, question 16 has been removed from the syllabus. Do not solve this question. Which statements about boiling and evaporation are both correct? Boiling takes place only at the surface. No, this is evaporation. Takes place through the liquid. Takes place only at the surface. Question 18. Question 18. On a cold day, a metal front door knob X and a similar plastic knob Y are at the same temperature. Why does X feel cooler to touch than Y? X is a metal. X is a metal. Why does it feel cooler to touch than Y? Because X is a better conductor. Metals are better conductors than plastics. Light travels at the speed of 2 times 10 to the power of 8 in a glass block. The glass, it has a wavelength of 4 times 10 to the negative 7. What's the frequency? Speed equals wavelength times frequency. So frequency equals speed over wavelength. 2 times 10 to the power of 8 over 4 times 10 to the negative 7. Again, when you are calculating this question on your calculator, please use the fraction sign. Please use the fraction sign. Do not use the divide sign. Because if you use the divide sign, you might forget to use the parentheses or the brackets. If you forget to use them, then the final answer would definitely be wrong. 2 times 10 to the power of 8 over 4 times 10 to the negative 7 is 5 times 10 to the power of 14 hertz. Amplitude would be B, not A. A is double the amplitude. The amplitude would be B. Scout P and Scout Q. Which mirror position allows the sunlight to be reflected to Scout Q? The sunlight is hitting, okay, Scout P at this angle. You need the angle to go back, or you need the ray to go back to Q. A lot of you would say D. A lot of you would say D. But actually D is wrong. Why? Because if the light is incident at this angle, if the light is incident at this angle, and you draw a normal, no, I'm drawing a normal, it will be reflected almost vertically downwards, almost vertically downwards. So meaning, this means that the light would hit the ground this way, which is wrong. Okay, we want the light to go all the way back to Scout Q, which is with a very small angle, with a very small angle. So definitely C is wrong. B would reflect back, which is wrong. And we need it to reflect downwards with a small angle, which is A. If you draw a normal, it would reflect downwards with a small angle. So it is A. Question 22. What is the angle theta? What is the angle theta? Prism is made from a transparent plastic. In the plastic, light travels at 0.8 c. 0.8 c, where c is the speed of light in air. In the plastic, light travels at 0.8 c, where c is the speed of light in air. Okay, and you have a prism, you have an angle theta, and it's quite obvious that this is the critical angle. It's quite obvious that this is the critical angle. Why is this the critical angle? Because the light is moving along the surface of the boundary. Now the light is moving along the surface of the boundary. Now this is the critical angle. What's the equation? How can we find the equation? What's the equation we use for the critical angle? N equals 1 over sine C. 1 over sine C, in which C is the critical angle, N is the refractive index. N is the refractive index. So to find C, it would be sine inverse 1 over N. 1 over the refractive index. We don't have the refractive index. How can I find the refractive index? The refractive index is, to calculate the refractive index, what do we say? It's the speed of light in air. Speed of light in air over speed of light in medium. We do not have the speed of light in the medium. We do memorize the speed of light in air, which is 3 times 10 to the power of 8. Do we have the speed of light in the medium? No. But we have that it's, he said that it's a 0.8 c. 0.8 c. You can calculate it. 0.8 times 3 times 10 to the power of 8 will give you whatever number. And, actually, we can do it in another way, which is c over 0.8 c. C over 0.8 c. C is the speed of light in air over 0.8 c, which is the speed of light in the medium. So this would give you 1 over 0.8. 1, 1 over 0.8. If you calculate this, it would be 1.25. This would be 2.25, which is the speed of light in, which is the refractive index. So C is sine inverse 1 over 1.25. Please differentiate between these two C's. This C is the critical angle. This C is the critical angle. This C is not the critical angle. This is the speed of light in air. This is the speed of light, which is 3 times 10 to the power of 8. If you calculate sine inverse, yeah, let's calculate it. Sine inverse 1 over 1.25 is 53 degrees. 53 degrees. Sun emits infrared radiation and light travels from the sun and reaches the earth in 8 minutes. In 8 minutes. What's the wavelength of the infrared radiation? We can just write them down. Rami looks great. So light infrared, the wavelength of the infrared would be longer. But the time taken would be the same. Why? Because they travel at the same speed. The same speed. A dolphin has a range of audible frequencies from 150 hertz to 150 kilohertz, 150,000 hertz. Which range of frequencies can be heard both by humans and by dolphins? By humans and dolphins. Humans can hear from 20 hertz all the way to 20,000 hertz or 20 kilohertz. Dolphins cannot hear below 150. Dolphins cannot hear below 150. So both humans and dolphins can start to hear from 150 hertz. Both humans and dolphins can hear these frequencies all the way up to 20 kilohertz. Why? Because humans can hear up to 20 kilohertz and dolphins can hear up to 20 kilohertz. Above that, it would be ultrasound for humans, but not ultrasound for dolphins. So dolphins can hear frequencies above 20 kilohertz. So the answer would be D. Permanent magnet is placed next to a soft iron bar. P and Q. P would be south and Q would be north. P would be south and Q would be north. A steel magnet is placed inside the wire, which demagnetization has been removed. Demagnetization has been removed. Magnetization and demagnetization of steel bars has been removed. Yeah. Electromotive force of a rechargeable battery is 6 volts. Okay, 6 volts. What does this mean? What does this mean? 6 joules is the maximum energy the battery can provide in 1 second. No. 6 joules is the total energy that can be provided before it has to be recharged. No. 6 joules of energy is provided to the battery to drive a charge of 1 coulomb around a complete circuit. Yes, to drive a charge of 1 coulomb energy per unit charge. This is the EMF, okay, or the voltage. How can I calculate the voltage or EMF or potential difference? It is the energy over the charge, E over Q, energy over charge, energy per unit charge. So 6 joules per unit charge. Okay, that's what I mean by volts. Volts are joules per charge. This one measures the potential difference. Which calculation gives the resistance? R equals V over I. Potential difference over current. C. V over I. يلا. A water heater is connected to 230 volts, current of 26 amperes. It takes 20 minutes. How much energy equals VIT? 230 times 26 times 20 minutes times 20 seconds. You have to convert the minutes into seconds. Okay, don't forget to convert the minutes into seconds. Times 26 times 20 times 60. This would give a total of 7,017,000. About 7.2 times 10 to the power of 6. Which electrical symbol represents a diode? B. We have a circuit. We have a circuit. What is the purpose of this circuit? Yalla, what's the purpose of this circuit? This is a bell. Okay, this is a bell, and this is a thermistor. So this is a thermistor. What happens when the thermistor? How do we affect the resistance of the thermistor? By changing the temperature. By changing the temperature. I don't care about dimmer. لا. No, we don't have a lamp أصلا, so A is wrong. To amplify the sound of a voice. Nope. A light lamp in the dark. Nope. So the only possible answer would be D. To sound the bell when the temperature rises. As the temperature rises, the resistance decreases and the voltage or the potential difference of the thermistor decreases. Therefore, the voltage or the potential difference of the bell would increase. Diagram shows two voltmeters P and Q. What happens to reading and on reading Q, on P and Q, as X is moved towards the top of the diagram? As X, okay, the pointer is moved upwards. As it moves upwards, voltmeter Q, the voltage would increase and the voltage here would decrease. The voltage would increase and the voltage would decrease. Okay, why? Because if, for example, X is pointing, okay, at this position, so P is only covering this part of the resistor. P is covering only this part of the resistor, meaning that the resistance would decrease. Okay, it's covering only part, a very small part of the resistor, meaning that the resistance decreases and the voltage decreases. So P would decrease, but Q would increase. Yeah, definitely this has been removed. Yeah, it has been removed from the syllabus. Question 34. Which statement about electromagnetic induction is correct? Electromagnetic induction is correct. A strong magnet held stationary near a stationary conductor causes a greater effect if they're both stationary. This is wrong. Nothing would happen. No motion, nothing would happen. The effect occurs when a magnet and a conductor are both moved in the same speed and in the same direction. In the same speed and the same direction, then there is no cutting. There is no cutting. If they're both moving in the same direction with the same speed, then no cutting would happen. Okay? No cutting. B is wrong. The effect occurs when the magnet is moved away. Okay? The effect occurs when the magnet is moved towards the conductor. إيه ده? They're almost the same. Both answers are almost the same, with a very, very slight difference, which is in D, he said that the effect only occurs when a magnet is moved towards a conductor, which is wrong. It could happen, okay, it could occur if the magnet is moving towards or away towards or away from the conductor. Okay, not only when it's moving towards, لا, when it's moving towards or away. So it has to be C. 35. Which diagram or which arrow shows the direction of the force? Which arrow shows the direction of the force on the wire? Definitely you will need to use Fleming's left-hand rule. Fleming's left-hand rule. Fleming's left-hand rule, in which the first finger or the index is from the north to the south, pointing to the left. The middle finger or the second finger is moving, okay, kind of into the paper, kind of into the page. Therefore, the thumb, which is the force on the wire, would be upwards. A. Fleming's left-hand rule. Okay, yeah. Question 36. Power losses in transmission cables are reduced by increasing the transmission voltage. Reduced by by increasing the transmission voltage. What is the explanation for this reduction? How can we reduce the power losses? By decreasing the current and reducing the thermal energy losses. Yes, that is correct. A. When we increase the voltage, when we increase the potential difference or the EMF or whatever, what happens to the current? The current decreases, and therefore the energy lost decreases. We have an atom. This central mass is the nucleus. The orbiting particles are the electrons. Nuclear fusion, okay, happens in stars. Nuclear fusion happens in stars. What does nuclear fusion mean? They are joining together. The energy is released. Stars produce huge amounts of energy. They don't absorb energy. We have a source and two different lines, two different paths. Two different paths. What is emitted by this source? One of them is attracted to the negative plate. One of them is attracted to the negative plate, and one of them is unaffected. This unaffected line would definitely be the gamma. The one attracted to the negative plate would be alpha, because the alpha is positively charged. So only alpha and gamma rays. The graph shows the count rate. صح. But you have some background radiation. Background radiation is 5 counts per minute. How do we solve this question? Minus, divide, plus. Minus, divide, plus. So initially it was 45. So 45. 45 minus 5 is 40. 40 divided by 2 is 20. 20 plus 5, which is 25, okay, minus, divide, plus, okay, plus 5 is 25. From 25, you can draw a line and then another line, which is 2 days, okay? Please, you can memorize this. Minus, divide, plus. Okay? Yeah, that's it.